All right. Well, good afternoon, everybody. It's 1 o'clock where I am, so I think it might be time to go ahead and get started. I just want to make sure that my audio looks good, and it does. Yeah, I hope everybody had a good day yesterday, and I hope it was a useful exercise. We're going to continue on from where we left off last time. I'll do a little bit of review just to make sure everybody is back on the same page and kind of aware of what we're doing. But one thing I do want to emphasize as we get started today is that this whole process is really going to be about scaffolding knowledge, right? So we're going to be taking the things that we're learning today and we're going to be building on them so we can develop something that does a little bit of useful analysis, that we might want to do, right? Excuse me. So it is a lot of information, and I am aware that sometimes it can get confusing pretty quickly. So if you do have a question, please put it in chat. I'm doing my best to keep an eye on chat. I have it pulled up here on my monitor. And yeah, let's go ahead and get started. Just as a reminder of what we did last time, all we've done up to this point is we've created a folder and we have saved one single Python script to that folder. I'll show you my desktop here. Let me minimize my terminal. And of course, I'm on a Windows machine here. And I know some of you are on Macs, but the story will be largely similar. So what I did last time is I simply created a folder that I called from 0 to n. And then inside that folder, I saved a Python script that I called basic Python. And in order to actually run that, we need to get into the terminal. And I have pinned the Anaconda prompt, which you can find in your Anaconda Navigator on Windows machines, to my taskbar. If you're on a Mac, again, your terminal is found in your applications in the utilities folder. And all I need to do to actually run my Python file is to change the directory to desktop, which is where I save that folder. And I'm on a Windows machine, so I use a backslash to represent the folder location. And I called it from 0 to n. And I can check what's inside that. That is dir on a Windows machine or ls on a Mac. And it'll tell me what is contained in this directory or in this folder. And we can see my basic Python file. Now, sometimes if you're using a Mac, you might see something like a .dsstore file. This is a hidden file on Macs that kind of tracks the history of the directory. Usually you're going to want to ignore that. But one thing to keep in mind is that your system will often hide files from you because it doesn't think you're going to need to interact with them. It might have things like directory histories or settings and these sorts of things. And by and large, you're going to want to just not deal with them. But this becomes a problem when you're running through a folder full of files using Python. Python doesn't necessarily know that you're going to want to ignore those files that start with a period, which are the hidden files. We'll get into that later when we deal with files. Probably not today, but maybe tomorrow. But just a heads up, sometimes if you see things in your directory listing that you don't actually see when you're in your file explorer. So for example, there are no hidden files here, but we can see basic Python. But in other cases, you'll see things that you list out that aren't visible in your file explorer. So just a heads up on that. And so we talked about a few different commands last time. We talked about just cd by itself on a Windows machine will tell you what your directory is. On a Mac, that is pwd. You can clear your screen on a Windows machine with cls or clear on a Mac. dir/ls is, of course, listing directory contents. What else did we talk about? We talked a little bit about remove directory or rm on a Mac. Again, that's not something that's going to be particularly critical in the things we're dealing with in this workshop. But these are handy things to know how to do. The most important thing for us to know how to do is know how to run a Python file. So again, Python by itself launches our interactive terminal. And so we can, run Python here. We can do fun things like list hello, and it'll create a list. We're going to talk about this later today. So we can just type Python in here, and we can quit it with quit. To run a file, we simply run Python space the name of the file, which always ends in a .py. It doesn't technically have to, but it should. And we can run this, and we can see here is what our script was doing. Also, we can say python-i basic Python, and it will run it, and then it'll drop us into this interpreter. So what we can do is we can actually, let's say we've written a program that does a lot of complicated things, and we're no longer sure what is in this myNumber variable. We can actually check myNumber, and we can see that it's 120, and we can then continue to write our script. But everything that we do inside this terminal is not actually going to affect that file. That file kind of lives by itself, and it exists in the state that we leave it in. Okay? One thing that I mentioned last time but kind of bears repeating is remember to save your file. Because last time I realized as I was typing this code, what I was doing was I was typing something and then I was hitting Control-S to save the file. And so one way you'll know whether or not you have saved it is if you're using VS Code, in the upper left-hand corner, let me actually make sure you're seeing my code. So if it is saved, in the upper left-hand corner, you have this document icon. If it has not been saved, if you've made changes, and if I say new var equals 10, you'll see here that there is a 1 here. So it actually tells you how many unsaved files you have open. And so this is a really handy way to know. Let's say I have typed print new var, and I have not saved my file, and I try to run my code again, and I'm going to get rid of this -i flag. Note that it's not actually printing that new variable, and I might wonder, well, what's the problem? Why is this not working? Well, it's actually for the very simple reason that I had not saved the code. So when I go ahead and run it again, now it actually prints off that 10. Okay? So just keep in mind that it's going to run whatever version exists as a saved file. It's not going to know changes you've made after you've saved it. Okay? So with that said, I think we can go on and start to learn a little bit more about the nuances of the data types that we were talking about last time. So as a reminder, we talked about integers, we talked about floating point numbers, strings, Booleans, none type, and we talked about creating variables and running functions. And the functions we ran last time are print and type. Okay? We're going to come back to functions later, but we're going to step back and I'm going to start a new script. And here I'm just going to go into my file and say new file. And I am going to save this. And I'm going to call it stringfun.py. Now, I should not call it string because that might confuse the Python interpreter because string is a reserved word. Well, str is, so string might actually be fine. But regardless, I'm going to call it stringfun.py. And we're going to kind of walk through some of the nuances of dealing with strings, because this is really what we're going to be interested in as people who want to do a little bit of text analysis. If we want to load in natural language representations into Python, often at the most basic level, we're going to be dealing with strings. Okay? So I'm going to create a variable, and I'm going to say useful methods for dealing with strings. And I'm going to say my string equals hello, how are you today? Okay? And I'm going to save it. So now what I have is a variable, my string, and its current value is hello, how are you today? Now, one of the really cool things about Python and a number of other programming languages is that most things in Python are what are known as objects. And essentially an object is something that exists in Python, for example, that has attributes and methods associated with it. So because this is a string, Python has a lot of built-in functionality that will tell us lots of useful things about this particular string. So something that I might want to do is I might look at this string and I might want to say, how many A's exist in this string? And so I can say something like my string dot count, and then inside parentheses, I'll give it an A inside quotation marks, okay? So when you're using parentheses in Python, by and large, this is a way of feeding information into methods and functions. The difference between methods and functions is I do believe it has a precise definition, but methods are associated with objects and functions exist kind of independently of those, right? So I have this string object and I am going to count A, okay? Now, right now, if I run this code, we can see here I have not saved it yet. So I will save this, and I'm going to hop over to my terminal, and I'll go ahead and clear this off, and I'll run python string fun.py. I run this, and it doesn't look like anything's happened, right? And that's fine. That we haven't told it to actually do anything with this information. So one thing we could do is, of course, we could print this. And remember, printing is just show this to me on the terminal. So I could say print mystring.count A. And it will tell me presumably 2 because there are 2 A's in this string. And when I run it, now we can see, in fact, that it says 2, right? Now, do note that this code on line 4 is functionally identical to hello, how are you today? .count A. So whenever we're using a variable, whatever is inside that variable is functionally identical to the object inside of it, if you kind of get what I mean, right? So these lines of code are going to give us the same information. So do be aware of that. Now, let's say I don't actually want to print this because once I print it, that information is just gone. I might actually want to save this in its own variable. So I could say a freak equals mystring.count A. And then I can print a freak, and it will go ahead and just print this. Now, this hopefully will be relatively clear. Remember, equal signs assign variables, and our variable name could be anything we please as long as it starts with a lowercase letter. It could be x10 or x1209 if we want. This is a valid variable name, and I could say x1209 here, and this will work just fine. Apologies, I just realized I'm not showing you my code. Yeah, yeah, I think I realized that as soon as. Thank you for pointing that out. That's my fault. What I'm gonna do is actually just show you my desktop rather than. So this way you're going to be seeing what I'm seeing. So this should actually be fine. Apologies for that. So essentially what we can do here is we can say, let's go back here. So I'm going to back up here, and I can save this mystring.count to a variable, for example, a frequency, and I can print a frequency. And this will operate just like I was directly printing this, okay? So when I run this string fun, it tells me 2 because the output has not actually changed at all. But What I also can do is, as long as this is a valid name, I can call this whatever I want. So for example, x1209, the output's still going to be the same. But as I mentioned last time, the really important thing to remember is that it's good to give your variables sensible names. So you want to be able to look at your code and kind of think about what's going on. So I'm going to change this back to a frequency. Okay? And so I've saved this into a variable so I can reuse this later in my code. Now, of course, I could break this down even further, and I could, instead of directly looking for the string a here, I could save a into another variable. I could say, for example, search term equals a, and then inside this parentheses, I'll just look for search term. And the advantage of doing something like this is that, let's say I have a bunch of code and I'm not exactly sure where I'm searching for this term, and I want to instead search for O. What I can do is I can change it in this variable, and it will now search for how many O's there are instead of searching for A's, right? So I'll get rid of these extra lines because obviously we don't need them. And I'll print a freak. And so now it'll actually print how often O's occur. Now, at this point, and you can see there are 4 O's in this string, but at this point, one obvious critique would be, well, my A frequency variable name now no longer makes any sense because actually I am searching for O's instead. And so maybe I'd rather call this term frequency, and then it will be a little more, it'll comport with, style guidelines. Now, obviously it will still work, but do kind of keep these sorts of things in mind as you're writing your code so it's obvious what's going on. There are a few nuances when it comes to this. So, for example, if I search for H and I print this, you might expect H and H both to show up. But when I run this, because Python is case sensitive, it actually tells me 1, because it thinks that this lowercase h and this capital H are distinct things. Okay? So keep that in mind. It will treat upper and lowercase things distinct. And do note that it doesn't pay attention to word boundaries. If I said something like, how are you today too, obviously not a very grammatical sentence, and I search for TO, it's going to find both this TO in today as well as the TO that to opens with, right? So when I run this, we can see that it in fact finds 2. So just kind of keep this in mind. If you try to use count to look for words in a document, sometimes the numbers are going to be a little bit off. And the reason for that is because of this. So for example, I actually knew somebody who wrote a paper many, many years ago, and he had written this paper about African American history, and he did a find all, but he had written using the term black in his paper. And when he wanted to replace all of the terms black with African American across his entire paper, but he forgot that his own last name was Black. And so then in kind of the authorship attribution, it changed it there too. So there's a similar sort of thing you have to keep in mind when you're dealing with Python. It doesn't, unless you're very specific about how you're doing it, it is not going to take those sorts of things into account. Because as I mentioned last time, computers are pretty dumb in some fundamentally kind of interesting ways. Okay? The next thing I kind of want to talk about here, and I'm going to just get rid of this. I'm going to comment out this print statement. And I want to now talk about something that is known as string concatenation. And that is simply adding 2 strings together. So I'm going to say string concatenation. Apologies again, I'm not sure how to spell this, but I think that's correct. So let's say I have a string, and I in this particular case, I can call it my second string, and this will be hello friend. And I have another string that is, I'll call it my third string, and this is how are you? So I can actually put these together with a simple operation. I can say combined string is going to equal my second string plus my third string. Now, something to keep in mind is that in addition operations like this, you can either have a space here or not. It's up to you. It's probably best to have one just because it looks a little bit better as it's spaced out. And so if I print combined string, this will add these two strings together and give me a longer string that says, hello friend, how are you? And so when I run this, we can see it says, hello friend, how are you? But do note that it just mashes these two strings together. We might, in fact, expect there to be a space between this exclamation point and the next sentence. So, of course, we can refine this ever so slightly by adding another term in here. We can add as many strings together as we please. So what we can do is we can do plus space plus my third string, right? And so when I add this extra space in here and I run this code again, I'll just clear off my screen. Now we can see that we have that nice space, right? So hopefully what this will emphasize to you is that Python is going to do exactly what you tell it to do, and it's not going to make really any assumptions outside of the assumptions that the actual syntax makes, right? So it doesn't know English, it doesn't know Chinese, it doesn't know Russian. It will just try to deal with these things as pretty undifferentiated objects. Okay, so we're going to have to get a little more sophisticated than this to do some cross-lingual analysis. Okay, so another important thing to know about strings, and here I will comment that out, is numbers, right? So let's say I have num1, and this is going to be 1, 2, 3, 4, and num2 equals 5, 6, 7, 8. Now, I can add strings together. It is perfectly valid. And I'll say new num is going to equal num1 plus num2. Because these are strings, I'll print this new number, and you can probably guess what the behavior is going to be. So the question would be, is it going to add these together as if they're numbers, or is it going to treat these as language? Well, the answer is that it's going to treat these as language, and our output is going to be 1, 2, 3, 4, 5, 6, 7, 8. And sometimes this is the behavior we want, and other times this is not the behavior we want. So if we actually wanted to add these numbers together, we would need to be sure that these are integers and not strings. Now, one thing you should be a little bit careful with is when you're trying to add integers and strings together, Python is not going to know how to deal with that, right? For example, here it's just going to tell you, I can't add an integer together with a string, okay? So Python was very good about kind of telling you these sorts of things, but it's good to be aware of these as you start to run into these problems as you're coding. One thing that I will highlight, and this I should have said this earlier, but it just occurred to me, is when you're working in Python, Python is what is known as a weakly typed language. That is, you don't have to specify what data type is going to be stored in any variable. If you're used to something like Java or C, you actually have to say, this is an integer specifically, this is a string, this is a float. Python will just try to figure that out for you. And most of the time, that actually works relatively well. But in other cases, it can't figure it out, and you're going to generate an error. So please do keep that in mind. We'll come back to kind of some operations we can do on strings to increase their number as we go a little bit farther forward. So hopefully that's a useful thing to know. Another very useful function that we're going to be using quite a bit in this class is length. Often we'll want to know how long a string is. So I'm just going to use my string up here because we already have this. And I'm going to check, get the length of the string. So I'm going to I'll say my string length equals len, and then in parentheses, my string. So what this is doing is this is taking my string from the top of my code there, and it's just checking how many characters are in this string. Now, this length function works with a lot of different objects in Python. It works with lists. I do believe it works with dictionaries and sets and various other things. But for strings, what the length is how many characters are in the string. So we can print my string length, and it will tell us how many characters are in this string. Note that it does not tell us how many words are in this string. So there are 30 characters in this string. Alternatively, we could, of course, directly print the length of the string rather than going through all of this rigmarole. We could say print length my string. So this is just essentially functionally exactly the same thing, because print just displays out to the terminal whatever we're working on, and length checks however long the object we give it is, and in this particular case, it's a string. Okay? So that is hopefully relatively straightforward. So far we've talked about adding strings together, we've talked about count, and we've talked about length. The next thing that we might want to do as we are working with strings is to get just a small subsection of a string, right? So often we want to get what are known as slices from a string. And so let's say we have my string, and we want to get the first character from this string. What we can do is we will use square brackets. So in Python, most objects, we can access information from inside of those objects using square brackets. So for lists, for strings, for dictionaries, we all use square brackets to access inside information. Yes, spaces are included in the count. Thank you. For how does length deal with byte versus double byte characters, it actually counts the Unicode characters, so it does not differentiate between bytes and double byte characters. This is a difference between Python 2 and Python 3. So for example, it used to be when you're programming in Python 2 and you're working with a string in Chinese where you have variable byte length characters, you might have some characters that are 2 bytes and some that are 4 bytes. And so if you have one 2 byte and one 4 byte character, the byte length of that string is 6. But in Python 3, it's 2 because it counts each character individually. So that's a very, very good question. And this is something that will throw you off if you've worked with Python 2 in the past. This is why Python 3 is much, much more intuitive. And so yeah, it is not aware of the byte size of individual characters. It just treats them as like self-contained units, essentially. And count does include spaces. So these are both very good questions. Spaces, punctuation, even sometimes it counts characters that don't display. Those are relatively uncommon, but they do exist, and sometimes you have to kind of be aware of that. Yeah, apologies. I realize those questions came perhaps as I was going on my lengthy diatribe here. But yeah, both good questions. Okay, so I was talking about getting information out of strings or out of any object. And as I was saying, most objects use this square bracket notation. And if I want to get the very first character out of my string, if we recall that is hello, how are you? So that should be this H. I want to go to the index of that character. So every character in a string has a number associated with it, and that is where in this string does it exist. And that H is at index 0. In many programming languages, indexing starts at 0. So the very first item is going to be item number 0. Some languages like R actually use 1-based indexing, but most programming languages start at 0. Okay? So if I print my string 0, this should print just that capital H. So I'll clear this off, and I'll run this. And you can see that it, in fact, does show that capital H. Okay? And that is the item that is at the first index in this string. We can also get the item that exists at the end of the string very, very easily. And so let me make sure I'm commenting here, get first character. And I can also get last character by printing. We don't have to print it, of course, but I want to see it. And inside of these square brackets, I can put -1. So essentially what this means is that when you use a negative number for your indexing, it's counting back from the end of the string. So -1 gives you your last character, which is perhaps a question mark. Yeah, it is indeed a question mark. So if we give it -2, it'll be the one right before this. And so this sort of reference system will also work for other object types in Python. And often what happens when, in a lot of programming languages, when we get to the end of an object and we keep going, it will flip back to the other side of the object. So there's actually a really famous example of this in computer games. And if you've ever played the game Civilization, you might be aware that India in that game has a tendency in the late game to become extraordinarily aggressive. And what's happening is this sort of indexing, because India in the game is one of the most pacifist countries. And what happens in the game is when the group reaches democracy, I think, at some point in the game what happens is once it gets to democracy, the aggression factor gets reduced by 2 or 3 points, something like this. But because India's aggression factor in the game is already so low, this pushes them into negative numbers, which actually flips them to the other side and makes them extraordinarily aggressive. And so, of course, the developers realized this relatively quickly, but by the time they put out the next game, it was kind of a meme, as we would call it now, and so it's stuck around since then. So it's this sort of negative indexing, or kind of flipping to the other side of a variable that causes that sort of thing to happen. Okay? Now, in many cases, we are going to want to get a substring, not just a single character, but a chunk of a string. So let's say we want the first 10 characters of my string. So to get the first 10 characters, what we can do is we can say my string, and inside these square brackets, I'll give it 2 numbers instead of 1. 2 instead of 1. I can start at 0, which is at the beginning, and I can use a colon 10. So what this will do is this will give me the characters from index 0 to index 9. So this last number is not included in this, in the output, okay? And so this, when I run this, it will just give me back my first 10 characters. And so you can see it's hello, comma, how with a space at the end, right? So 5, 6, 7, 8, 9, 10. This space I think is just my terminal. So it gives us the first 10 characters. One thing to know, though, is that this 0 here is actually not necessary. If there's nothing before this colon, then it will just start, it'll guess where to start from, and in this case, it's just at the beginning. We can use this to get specific ranges as well. So let's say we want to get characters 4 to 12. We can do the exact same thing. I'm going to copy this, and we're going to start at 4, and we're going to go to 13 because we want to include the 12th character. Okay? And when I run this, now we can see that it goes from O to R, right? That's simple enough. We can also go from a certain character to the end of the string, and that format is essentially just like this. So let's say from character 10 to the end. In this case, we want the 10 before the colon. And because there's nothing here, it just sends us to the end of the string. And so I'll print this. And you can see are you today 2 is the rest of this particular string. So in what circumstance might this be useful? Well, we can actually couple this with functions like, or methods like find to, extract out from a string a substring. So for example, I could say, let's say find a substring. So now what I'm going to do is, let's say I have I'll just call this greeting, and I'll say hello, my name is Paul. So I might want to find where my name occurs in this particular string. So I can say something like result equals greeting dot find, and then I'll look for Paul. Okay? So what this will do is this will find the index of this string Paul. So it's going to return to me an integer, and it will be whatever the integer of this substring is. Okay? And so if I print this result, print result, it occurs at index 18. Now, there are a couple of nuances when it comes to working with this particular method, right? So the first thing is this find function will only find the first example of a substring. So if, for example, we add name here, so hello, my name is Paul, name, and if I look for name instead of Paul, it's only going to give me the location of this name, not this name. Okay, and so this is going to be probably something like 11. It's 10. Okay, so just be aware of that. Python does not have a find all functionality. There are ways, of course, of writing our own, and we might get to that in this workshop. But do be aware of this fact. Another thing to keep in mind is that if the string is not, the substring is not in your string, it will give you back a -1. So let's say instead of name, I look for how. When I run this, it's going to spit out a -1. So when you're going to search for a term and then do something with that term, you're going to want to check, is it a -1 or is it not a -1? And this can lead to some odd behaviors if you are not ready for it. Because if you search for a term, it gives you back the -1 and you assume that in fact you found it, you're going to be sent to the last character in your string. So just just be a little bit careful when it comes to that. I'm also going to show you a couple of handy methods associated with these strings that will let us create new strings out of the strings that we already have. I should point out that there are certain data types in Python that are known as immutable. That is, you can't change them without erasing them and redoing them. And strings are one of these. So you can't technically create a string, and your computer can't go in and change that string in memory in Python. It has to kind of change it and save it as a new object. I think for everything we're going to do in this, that's not a hugely critical distinction, but, you know, the more you know, I guess. One thing we could do here is, let's say we want to create a new string, but we want to replace all of the A's in this string with O's. So this is string replacement. And what we can do is I can say A, O mix. This is going to equal greeting dot replace A, comma, O. So what this will do is this will just go into this string greeting, and it will replace all of the A's with O's. It's pretty simple, pretty straightforward. And I can print A, O mix, and I will run this Python string fun, and we can say hello, my nom is Paul, nom. Okay, so this will be useful in certain cases where we're trying to replace a bunch of spaces with something, or there is a common spelling error that you want to fix, and replace will come up quite a bit. You can, of course, replace multiple characters all at once. We could replace AU with OO and print AO mix. And when I run this, we can say, you know, my name is Pool, right? And so it matches AUs and replaces them with O's. But do keep in mind that greeting itself does not change at all. It will still be this original hello, my name is Paul name. Okay, so I'll print both of them, and you can see that the original string has not changed. That is still available for us to do whatever we want. Now, if we wanted to actually change the string destructively, what we can do is we can run this greeting replace just like this, but then we can say greeting equals greeting. Okay? So what will happen, what Python does, is it goes in and it grabs the string greeting, it replaces AU with OO, and then it saves that replacement back to this greeting variable, and that will change it for good. Okay? So when I run this, and I may not have saved it, I don't think I did. Yep, I forgot to save it, so you can see that it's still 1 here. When I run this, now you can see that the second time it has greeting has changed because I have saved back over that variable. So what else did I want to say about strings? Yes, so there are a few other things that we might want to do with strings. We can check various things like, are there numbers in it? Are there decimals? Is it numeric? But I want to be mindful of our time, and so I'll just share with you a couple ways of changing them. So let's say I have a lowercase string, and this is going to equal, we'll just call this editing our string. And let's say this is a lowercase string, no uppercase here. I can actually use a few methods associated with strings to change this. So for example, let's say I wanted to capitalize it. I can call the capitalize method, which is capitalize and then open and close parentheses, and I can run that. And when I do that, we can see that that string now has a capital T, so it's been capitalized, right? So this will capitalize the first letter of every sentence, I believe. Let me double check. It might actually just be the very first letter of the string, because if I put a period here, let's see if it capitalizes the no. Yeah, so that just capitalizes the very first letter of the string, not the, it doesn't pay attention to the nature of the language. So do be aware of that. Another thing we could do is we could also print lowercase string. We could make everything uppercase with upper. So when I print that, that capitalizes every letter in the string. And this can be useful to do sometimes if you don't want to deal with the fact that there are capital and lowercase letters. You just want to kind of treat everything equally. There is also a lower function, but of course this is already all lower, so it's not going to really do anything for you. But just know that that also exists. So that is what I kind of wanted to say about strings for the moment. And I think that's most of what you're going to need to know to do the exercises that we're going to get to later in this workshop series. Before I start talking a little bit about math in Python, does anybody have any questions? This is quick, I do realize, but like I say, we're going to be putting the little building blocks together that are going to help us get to some interesting places. If there aren't any questions, I can go ahead and grab the math. And so we're going to talk a little bit about doing math in Python. Python is really handy in that it gives you all sorts of useful functions to perform statistical analyses, just basic arithmetic, linear algebra. There are all sorts of things you can do that you can do with Python. Sometimes you'll need extra libraries, in other cases you won't. But we'll start diving into the very basics of that. So I'm going to go ahead and open a new script, and I'm just going to call this one mathfun.py. And I'm saving this into the same folder as this other script. So now we have basic Python, mathfun, and stringfun. There's nothing in mathfun quite yet. But let's go ahead and change that. All of your basic mathematical operators are available in Python for you to use. So addition in Python is very simple. It uses the plus sign, right? So 10 plus 10. And we'll go ahead and save this as add integers and 10 plus 10. And I'll go ahead and print this. And of course the answer is 20. But we'll print everything just so you can see what the output of all of this is. And so I'll clear this and I'll run Python mathfun. We can see that the answer is indeed 20. Now, if you add two integers together, you will always get back an integer. But you can also add floats together. So let's say add floats. And this is 10.0 plus 10.0, this will always return a float. So if I print add floats, what we'll see is that it will return 20.0, okay? One thing that you might not expect is the behavior when you add an integer to a float. And we'll say add int float equals 10 plus 10.0. This will also give you back a float. So I'll print add int floats. Now we can see that we have 20, 20.0, and 20.0. Okay? That's simple enough. Other things that I probably don't need to spend too much time on, 10 minus 5. So subtraction uses the negative sign. Multiplication uses the star. So 10 times 5 is going to be 50. And division is going to be with the slash. So 10 divided by 2. Now, be aware of a nuance that's going to happen here. Let's say 10 divided by 2, and we'll go ahead and print all of these. We'll say print 10 divided by 2. I don't think we really need to print those. So you can see that 10 divided by 2 equals 5.0. In Python 3, when you do division, by default, you will always get a float back. So if we do 10 divided by 3, we're going to see that it is 3.33333, and then we have a 5 at the end because it can't go off into infinity, and there is a little bit of imprecision involved in floating point number calculations. In Python 2, if you divided two integers from each other, you would always get an integer back. So this is a difference between Python 2 and 3. Although I guess it's been so long since Python 2 has really been widely used, maybe I don't need to keep talking about this. But if we want the old behavior, and we want integer division, what we can do is we can simply use two dividing signs. And the way that integer division works is it just drops off the remainder. So it'll give us 3 instead of 3.33. And this is useful in certain cases when we want to loop across a string a certain number of times and we don't want to be dealing with floats. But just kind of be aware that this is a behavior in Python. There are a few other basic mathematical operators. There is something known as the modulo. So we can get a remainder with modulo. And so we can do print, in this case, 10 %3. So the percent sign is actually a modulo, and this should return 1 because 10 divided by 3 has a remainder of 1. And so when we run this, we can see that this is a 1, right? This is actually extremely useful for checking whether or not a number is even or odd, because if you modulo 2, if it's even, the answer is always going to be 0. And if it's odd, the answer is always going to be 1. So it's a very handy way of checking if a number is even or odd. We can get exponents. If, for example, we wanted to get 3 squared, we simply do star star 2. Right? 3 star star 4 is 3 to the 4th power. So pretty simple, just star star. That doesn't come up quite as often as the other mathematical operations, but it is a good thing to know. We can do math with strings. Well, we can do some math with strings. So if I had my string equals yo, like this, if I print my string and I multiply it times 5, it will actually print yo 5 times. So when you do math on strings, or at least additive math, it will just combine them in this way. Note that you can't divide a string by 3, for example. It's not going to know how to deal with that. So, for example, if we tried to divide this by 5, it's going to give us an error and I think tell us that this data type simply is not, It's going to say unsupported operand type for string and integer because it doesn't know how to divide a string by 3. So we'll leave this at multiplied times 5. Sometimes you might not be aware of what type of object exists inside a variable. So for example, if I say my num equals 10 times 1.3, or let's just say 1.0, I might not be aware that Python will coerce this into a float. It'll turn this into a float. So what I can do is I can check the type of my num. And we talked a little bit about this at the very end of yesterday's session. So when I run this, we can see that this is in fact a float. Now, one thing we can actually do is, what if we don't want this as a float? What if we want this as an integer? Well, there is something known as type coercion in Python, where we can actually take a float and turn it into an integer by saying my num equals int my num. So what this will do is this will take whatever is in my num and try to turn it into an integer. And so what I can do, we can check that this works by again printing type my num. And now we can see that it was a float and then it becomes an integer. Okay? Of course, we can also use other things. We can turn things into strings. We can turn things into floats. And yeah, so those are kind of the basic type coercions that you can do. Do be aware that you can turn some strings into integers. So for example, I can turn the string 3 into an integer, but if I try to turn the string hello into an integer, it's going to fail, right? So it is sometimes necessary to keep track of what's going on inside all of your different variables. I hope this has not been too confusing. We're starting to step into some really interesting territory, but I've been talking already for an hour now, and we've talked about strings, and we've talked a little bit about math. I do want to get through two more things today. I want to talk about lists, which are objects that will let us store multiple different values at the same time. And then I want to talk about Boolean expressions and kind of if-else statements, because we're going to want to start to think about doing different things based on the state of our program. And we're going to need those to do text analysis. So what I think I'd like to do now is take questions and then take a couple-minute break and then get back at it to talk about lists. Does anybody have any questions? If not, I'm going to go ahead and take a very quick break and then come back in a couple minutes. Everything's clear. Good. One thing I do worry about sometimes is I tend to move very quickly. I think my students can sometimes attest to this. And I can get excited because I find this all very fascinating. But yeah, we'll come back in 3 minutes and continue on with our discussion. Be back in 3. All right. Sorry about that. Thanks for indulging me. Just got a little bit more water here. Okay, so why do we care if a number is a float or an integer when dealing with text analysis? I would say most of the time it's not going to be something that's going to matter a lot to us. Like I mentioned in class last time, it matters when when you need a very, very high degree of precision, because our computers are in binary. A floating point number can't be represented completely precisely in the computer's memory. And so there's always a little bit of wiggle room when dealing with floats. But for most of our purposes, we're going to be dealing with integers. We're going to be dealing with things like how many times does this word occur in a document. But we're also going to be looking at word rates, like how many times per 1,000 words does this word occur? And that's going to be a float, and it's going to be necessary to just be aware that Python understands these in slightly different ways. I don't think, or I can't think immediately off the top of my head, any instance where I really ran into a big issue because I wasn't sure if something was a float or an integer, because in many cases, like when you start to get into things like text classification and machine learning, you're only dealing with floating point numbers, or you're dealing with labels, which tend to be categorical and often displayed in integers. So, I don't know. I think it's just important because it's good to have a good base in Python and how it understands numbers. But yeah, I can't really immediately think of somewhere where it would be a problem, but I'll think about it, and as we kind of go through, I'll point out places where this isn't going to work if it's a float versus an integer. Actually, I can think of one instance or one case where we might want to know this. So in many times, we might want to take a document and break it apart into equal-sized chunks. And so what that will often do is, let's say, we can either say, I want to take this text and I want to break it apart into 5 different chunks, or let's say 10,000 word long chunks, okay? And so what I would do is I would say, let's take the whole length of this text in words, let's divide that by 10,000, and what that result is how many times I would loop through the text to get those chunks. Okay, and so that's not going to work if it's a float. It's going to have to be an integer. But that being said, that's kind of an odd case where it's probably going to be pretty clear from the context of your code that you're working with integers, and it's not really going to be that big of a deal. So that is a case where you would want to be working with integers, but Python's going to want to give you floats, and you're going to have to deal with that. I'm not sure I was going to show doing something like that in this workshop, but it is something that I occasionally need to do, and maybe it is a good example to work on. Okay. All right. So I think we should move on and start to talk about not basic data types, but slightly more complex ones. Although I'm sure there are Python developers out there who would tell me that lists are basic data types. Anyway, it doesn't matter so much. So let's hop back in it and let's start a new file that I'm just going to call listfun.py. Do note that if you're working on a Macintosh or a Windows machine, all of this is going to be exactly the same. The only times we're going to need to be aware of system-based differences is when we work with files, which we'll get to probably tomorrow. And I'll show you in those cases the best way to deal with that. So let's talk about lists. Lists. So all a list is an ordered container for information / Python objects, okay? And so the syntax to create a list is pretty basic. So we're going to create a list with square brackets, and each item is separated with a comma. Okay? So let's say I have my list, or let's say I'll call this name list. And I'm going to use square brackets, just like this. And inside this name, I'm going to have something like Juan, Roger, Ying, Cindy, and so on. Okay? So here we have a list. And inside this list, we have 4 different items. We have Juan, Roger, Ying, and Cindy. Okay? So Python knows this is a list because it starts with a square bracket, it ends with a square bracket, and the items are separated by commas. So this is a list of strings. But note that a list can hold any arbitrary Python data type. But a list can be empty. So we can call this an empty list. And this empty list here is going to be a very useful construct for us because often we're going to want to execute the same chunk of code again and again and maybe save the results of that code into an empty list. Of course, calling it an empty list, if it's eventually not going to be empty, a little bit problematic, but it is what it is. And of course, we could just call it empty, but I often like to make it clear the kind of data or the data type of the object in the variable name. Not strictly necessary, but it is, it is nice if other people are going to be seeing your code. So the list can contain basic data types. So for example, I can have an int list, and I can have 1, 2, 3, 4, 5, 6, 7. I could also have a float list. And it could be, 1.0, 3.4, negative 0.5, and so on. You can also mix your data types. You can mix data types. This is perhaps not great practice, but I'll just call this mixed list. And this has a 1, hello, and perhaps a 4.4. Python at the syntax level is perfectly happy with letting you do this. In practice, it's good to not do this because often you're going to be iterating through lists and doing the same thing on every item. And if they're not all the same kind, it might introduce problems down the road. You can also have lists of lists. So for example, I'll just call this list, and I can have 1.3, 2.4, comma 6, comma tree, rock, boat, gorge, for example. This is perfectly valid. You can have as deeply nested lists as you want. Okay? One thing to know is that lists always keep the same order. And so however you create the list, those items inside of that list are not going to move around at all. So let's say I have an int list here, and that int list is 4, 12, negative 1, 2, 5, right? If I want to get the first item in that list, oops, I need an equal sign here. If I want to get the first item from this list, I use the same notation as with strings. So for example, print first item. I'll print int list, and then inside square brackets, I'll do 0, right? And so what this will do is this will go into the first index of this list, and in this case, that's a 4. It will grab that and give it back to me, okay? And so when I print this, it will print 4. So let's hop over to our terminal, and let's clear this, And let's run Python list fun. And we can see that it prints 4. Okay? And just like with strings, we can also print the last item, print last item, if we give it a -1. So that should print 5. Yep, just like that. So that is relatively easy. We can also get slices of lists. So get a slice from a list. And this is exactly like with strings, where we'll simply say int list. And I'll print it just so it shows up on the terminal. Let's say int list. Oops. Int list. Square brackets. If I want to get the second to the 4th item, I'll do 2:4. You know, if I want to go from the start, it is colon to the index I want to go to. If I want to go to the end, you give it the start index colon to the end, right? So when I print this, it will give me items 2 and 3, which are -1 and 2. So relatively simple. Once you understand how indexing works with strings, it works essentially identical in lists. But in many cases, when you want to find something in the list, the search term is not find like it is for strings. It is instead index. So let's say I want to find where is this -1 inside this list. So get index of -1. So here I'll simply say int list index -1. And what that will do is that will return to me the index, so that should be 0, 1, 2. So if I print this, this should be 2. So it checks, let's see. Yeah, and so it checks in and it gets 2. So let's see. Oh yeah, sorry, I misspoke. The 2 to 4 gets the 3rd and 4th item. So let's go back here to, so here it's the item at index 2 to the item at index 3, because remember this last number is, it doesn't get included, right? So this is index 0, index 1, index 2, and index 3. So to get 2:4 goes from index 2 to index 3. And that is item number 3 and item number 4. So apologies if that gets a little bit confusing. You'll get used to it, but as you first encounter it, it can be a little bit mind-bending. So hopefully that clarifies a little bit, but you're definitely right. 0 is the first and 1 is the second. So let's see here. Editing lists is really simple. Unlike strings, a list is mutable, so you can change it. So for example, let's say on my list here, I wanted to change this -1 to a 10. All I need to do is, let's see here. Let's see, change value in list. All I need to do is I need to say int list at index 2, so that is the 3rd item, -1, equals 10. So what this will do is this will take 10, and it will insert 10 into index, the item at index 2. Okay, so it'll replace -1 with 10. So when I print int list, what we'll see is that -1 is replaced with a 10. Okay? Often we'll want to add things to lists. So add an item to a list. And we can do this simply with the append function, or the method. So we're going to append the number 6. So what this will do is this will just add a 6 onto the end of this list. Okay? So I'll print this again, int list, And we can see that now it adds a 6 to the end of the list. So that is simple enough. We can remove items from these lists with pop. So remove item from list. We can say int list.pop with these parentheses. If we don't specify a number here, it will just remove whatever item is from it gets from the end of the list. So in this case, we'll print int list again, and it will get rid of that 6. Okay? We can also tell it the index of the item we want to remove. So if instead of making this empty like this, if we had said 1, what this will do is this will remove this 12. Okay? So we'll do int list.pop1, and we can print this. And we can see that instead of removing the 6, it actually removed the 12, which is the item at index 1. Now, let's say you want to remove an item from a list, but you actually want to do something with that value. Pop will actually give you back that value. So we could say removed value equals int list.pop1, and then we can print int list and print removed value. And that should contain a 12. So you can see that pop actually deletes it from the list, but it also gives it back to you in case you might want to do something with it. Because sometimes you are going to want to use it for whatever. And we'll perhaps encounter this, although actually I don't ever use pop for whatever reason. It's not something that ever comes up in the coding that I tend to do. The other thing to know about lists is you can add values at specific indices. So we can add value at index. And we can just do that with int list.insert. At index 1, let's add, let's say, 42. And we will print int list, just like this. Insert's another thing that I don't use very often, but it is still good to know about. And now you can see that it inserts a 42 at index 1, and it pushes all the numbers back. Okay? That is relatively straightforward, I hope. So really, the things that we're going to be using most often as we write code for the digital humanities is we're going to be doing a lot of usually searching within these lists, maybe doing some index or list slicing, and appending. Appending is going to be one thing that is going to come up again and again and again. There are a few other things we can do with lists that are good to know about. So let's see here. Let's say, again, we can turn strings into lists. So a lot of data types in Python, we can convert back and forth to each other. So for example, I have greeting again, and I'm just going to bring back hello, my name is Paul. I can turn this into a list. So turn into a list simply by saying greeting list equals list greeting. Okay? So what this will do is this will take the string, hello, my name is Paul, and it will convert it into a list using its default assumptions. And so let's print greeting list just like this so you can see what it does. You can see that it creates this list, HELLO, comma, space, MY, comma, NAM, space, and so on. You get it, right? So basically, by default, list will turn a string into a list of the individual characters in that string. That's fair enough. But often that is not precisely what we want to do. In some cases, we might want to try to break this apart into a list of words. Now, to do this precisely does require relatively advanced pattern matching or natural language processing, but we can actually do a pretty quick way just using this list function, or excuse me, not using the list function, but using the split function. So let's say I want to say greeting words equals greeting, and I'm going to split along the space. Okay, so split here is a string method that is associated with this string, and it's telling it turn this string into a list using the space as a guide. Okay, so in the resulting list there will be no spaces, but every item that is separated by a space will be an item in this list. So we'll say greeting words, let's print greeting words, just like that. So when I do this, now we can see that we have hello, my name is Paul. So this is actually pretty close to a word tokenizer, right? I mean, we can see that it isn't precisely because we have a comma inside this, and Python is not sure how to handle this because we haven't told it. There are more advanced ways of dealing with this using regular expressions or the natural language toolkit that we will probably get to tomorrow. But this is really the easiest way of doing this very, very quickly. And one thing you could do is you could just go through and filter out this comma. That's kind of up to you, but we will come back to this as we move forward. So this is a very useful thing. So more turn into list. So note, however, that this space, this can be whatever we want it to be. So we could, for example, make this A, right? If I make this an A, that output list is going to look quite a bit different. Hello, my N, me is P, U, L. Okay? So we can give it an arbitrary string. We could also say name. It doesn't need to be a single character. We could run it just like this, and we can see hello, my space is Paul. Okay? But space is a really handy thing to split along. We can also turn back into list very easily. So we can take a list and we can join it together into a string using a different string method called join. So I'll just say new greeting is going to equal space. So here this is a string. This is one of the syntax choices in Python that I find a little bit confusing because it's a string method rather than a list method. So space dot join greeting words. So what this will do is this will take this list. We're actually back to this particular state. It'll take this list and it will combine it together using a space as glue. So this will basically just give us back our original string. So let's go ahead and print new greeting. Okay, so when I do this, you can see that it is just hello, my name is Paul. So that is hopefully relatively simple. A couple final things about lists. So we can get the length of a list with len. So this is just like strings. And so let's just use int list. And so what this will tell us is how many elements are in the list. So it'll say for this particular list, it'll be 1, 2, 3, 4, 5. So it has a length of 5. For this list, it will have a length of 3 because it'll only see 1, 2, 3. So it doesn't peer into the list. It just looks at that first level. So that'll tell you how many items are in the list. You can also check the min value of the list. That is, whichever item has the lowest value. There's also max int list. So this will give you the maximum value. We can also reverse a list quite easily by saying int list dot reverse. And so if we print int list here, we can see, oops, sorry about that. we can see that it goes from 4, 42, 10, 2, 5, 6 to 6, 5, 2, 10, 42, 4. All right, that's simple enough. And the last thing that we might want to do is we might want to actually sort this list. So there are a few different ways of sorting a list, but really, let's see, I think you can still do this. Int list.sort, and then print int list. So do note that all of this is happening in place. So you can see it becomes 2, 4, 5, 6, 10, 42. So I am not reassigning these values to a variable. I'm just sorting them in place. We can also tell this to sort in reverse by saying reverse equals true inside these parentheses. And now it will go from the largest value to the smallest value. So 42, 10, 6, 5, 4, and 2. So lists are going to be extremely useful for us as we go on to do some analysis, which I'm actually hopeful that we'll get to tomorrow, because the last thing I wanted to talk about today are Booleans and Boolean operators. That is, checking if a value is true or false, and then doing something different depending on what that answer is. But before I move on to Boolean values, does anybody have any questions? Yes, with a list of strings, sort will alphabetize. Good question. So for example, let's go back over here and let's say, I think I have a list of strings. Yeah, so name list. So if we say name list sort, and then print name list, it will sort it in alphabetical order. So Cindy, Juan, Roger, Ying. So yeah, and that's a pretty handy thing to do. In some cases, it depends on the language you're working on, how exactly that will handle it. So I think if it sorts Chinese, it sorts by the Kangxi radical and by stroke count. So it's going to be pretty similar to a dictionary-based sort. For other languages, it's going to usually follow whatever convention that language tends to use. But yeah, that's a good question. Any other questions before we spend the last, half an hour talking about Booleans? Maybe we will actually not make it all the way to 3, but that should be fine. So let's see. Let's go ahead and talk about the last thing I want to talk about today, which are Booleans. That is true and false. So what I want to do is I want to start a new file, and I'll call this boolfun.py, and just saving it in the same place that all of my other files are. So, the code in the list here. And do note that I will upload all of this to GitHub this evening. I put yesterday's code up already, and this will be going up probably as soon as we wrap up for the day. So hopefully that will be handy. All right, so I'm going to go ahead and jump into the Boolean discussion now. And then this is basically, I think, the last component we're going to need to start building things. We're going to talk about loops next time, and then basically we're ready to start doing some super basic analysis, and then we'll get a little bit more advanced as we go on from there. So Boolean operators and Boolean objects are really one of the keys to making programs do complex operations, and they let us compare different values to check if they're equal to, have our code branch and do different things. Okay, so what we're interested in here, Boolean operators. So we want to create expressions that evaluate to either true or false. Okay, And so in Python, we have a few different ways of doing this. And to test if two values are equal to each other, test if two values are equal to each other, we use two equal signs. Okay, so 5 equals 5. Okay, this will evaluate to true. Okay, and note that there are exactly two equal signs here, and that is because the single equal sign is used to assign variables. So we're using two equal signs. There are other ways of checking equality that we might talk a little bit about, but if you've ever, used JavaScript, you might use two equal signs or sometimes even three, which is an even more strictly enforced equality, but we're using two here. Note that, for example, we can also check equivalence of strings. So A equals A, true. But of course, if we try to say 5 equals 6, this will evaluate to false. Okay? That should be simple enough. In many cases, we want to test if two values are not equal to each other. In this case, we'll say 5 exclamation point equals 5. This, of course, evaluates to false because actually they do equal each other, so this statement is incorrect. So 5 does not equal 6, evaluates to true. Okay? Hopefully that makes sense. So the exclamation point in Python is essentially negating that equal sign. We can also check if one number is smaller than another. So is 5 less than 6? That is true. Is 6 less than 5? That is false. Larger than is the opposite. So 5 greater than 6 is false. 6 greater than 5 is true. And so the way that I remember this, this goes way back to when I was in like 2nd grade. And the teacher told us to think of this greater than sign, the less than sign, whichever way it's facing is going to be toward the bigger number if it's going to evaluate to true. And she suggested that we should think of this as an alligator that wants to eat the bigger number, right? So 5 is less than 6. They should be facing the bigger number if it's true, right? And in this case, the greater than sign is facing the bigger number. Anyway, that's how I remember it. Maybe that's not super useful, but that kind of gives you a sense of where I'm coming from. Of course, in many cases, we want to say greater than, well, let's just say less than or equal to. So if we want to check, is 6 less than or equal to 6? This will be true. Is 6 less than or equal to 7? That is also true. But is 6 less than or equal to 5? That's false. And that hopefully makes sense. So greater than or equal to is just the opposite. So we can say 6 is greater than or equal to 6. That is true. 6 is greater than or equal to 7. That is false. And 6 is greater than or equal to 5. That is also true. Okay? So this is kind of, pretty straightforward operations, right? We can also check if two variables are the same object. And this is where things are going to get a little bit strange. So I'm going to print the results for you. Let's say we have A equals a list that is hello, and we have B equals a list that is hello. So one thing I can do is I can check, are these equal to each other? So if I print A equals B and I run this code, so we'll say Python bool fun, we can see that that's true. So I'll run that again so you can see that. We can see that A does in fact equal B. And that makes sense, right? So A is a list that says hello, and B is a list that is hello. But I can also print A is B, right? And this is thing basically says, are these the same object in memory? And in this case, that is false. So that's sometimes a useful thing to know. But for example, if I said C equals B and then print C is B, that should be true. Yeah, and you can see it evaluated as true. Okay? Sometimes there are things that we want to do in our code. We might want to check, is an item in a list? So, for example, let's imagine that I have check if item in list. So let's say I have our int list, and I'm going to comment these print statements out so they don't print things anymore. I'm going to say I have 1, 2, 3, 4, 5. I might want to check, is 4 in this list? Print 4 in int list. Okay? So basically, this is just saying, is 4 in int list? And we can see that 4 is indeed in this integer list. But if we instead say 6 in int list, it will say false. Okay? We'll be doing a lot of this as we go forward. So what is the utility of this, right? Like, why does this matter? Well, we can use statements in Python to do one thing if something's true and to do something else if it is not the case, okay? And so I'm going to introduce a new concept that is the code block. Now, if you've programmed in other languages, this is going to be a little bit different. And this is one place where Python is a little bit weird. Let's say I want to do something if 10 is less than 20. So I can say if 10 less than 20, colon, and then a new line that starts with a tab, or 4 spaces here, then execute this code if statement is true. Okay? So whatever I put in this code block, that is, whatever is indented out one level, will run if 10 is less than 20. And I'm going to print exactly. Okay? And I can keep going, print hello. And so this should print exactly and hello when I run this. So you can see it printed exactly and hello, and it did that because 10 is less than 20. But if I switch this and I say if 10 is greater than 20, print exactly and hello, if I run this, it does not print those anymore. Okay? So one thing to know is that it will run this code, but then if I want to keep going and I want more code, I can remove the indent, and then I can print kept going after code block. Okay? So what will happen is this statement is going to evaluate to false, and so it's just going to skip everything that's in here, and it's going to go down to when it sees no indentation anymore, and it's going to keep running. So when I run this, it says kept going after code block. Okay? So that is an important thing to keep in mind, is if this is false, it'll just skip over whatever going on there. So we often want to make this even more sophisticated. So we can also say if something, otherwise do something else. So if 30 is less than 20, I'm going to say print, hey, isn't it weird that 30 is smaller than 20? Else, print, of course, 30 is not smaller than 20. So when we run this code, 30 is, of course, never going to be smaller than 20, so it will never print this line. It will always print, of course, 30 is not smaller than 20. And we can run this code to make sure that that's true. And we can see that, yes, indeed, of course, 30 is not smaller than 20. Simple enough. But we can add more conditions if we want. So we can also say if 10 is greater than 10, we can, let's say, make a new variable. We'll say 10 is larger than 10. To add extra options, we can say elif. So we can add more Boolean statements. If 10 equals 10, we can say 10 is 10. And then we can perhaps add another one. Elif 10 is less than 10. A equals 10 is smaller than 10. And so on and so forth. Else A equals no idea, right? And then at the end of this, we can print A to see what happens. So obviously 10 equals 10, so A should end up equaling 10 is 10. So let's see if that works. And of course it does. Okay? There is one thing that you need to keep in mind when you start building these else, elif, if, elif, else statements. And that is that as soon as one of these statements evaluates to true, it stops. It stops, it grabs that value, and then it moves on to everything that comes after that code block. So I'll give you an example of when this might be a problem. So let's say we have a value, and we're just going to say y equals 10. Then we're going to say if a is greater than 1, if y is greater than 1, then we can say z equals y is closest to 1. Then we can say elif y is greater than 5, z equals y is closest to 5. Elif, let's say y equals 10, z equals y is 10. And then we'll just, and note when you have elif statements, you don't actually need an else, but I'll just say z equals no idea. So when I print z, which is going to be assigned inside this statement, it's going to tell me y is closest to 1. Now, hopefully you can see why this is a problem, because in fact y does equal 10, but as soon as it saw a true value, it said, okay, we've got this. We're done with this if, elif statement. Let's just move on and keep going. So if you're not aware of this behavior, this might cause some trouble when you start to write relatively complicated code. Two last things before I leave it off, and I'll answer any questions you have, and hopefully you can let this sink in, and next time we're going to start to do some really fun things, I think. We can make more complex statements, right? So we can say, let's say we have I equals 6. Then I can check if I is less than 10 and I is greater than 5. So we can use and to make a more complex sentence. And we can just say print this is true. And so this will print this is true because it is between those two numbers. Of course, there is also or. So for an and statement to evaluate to true, this needs to be true and this needs to be true. For an or statement to evaluate to be true, this needs to be true or this needs to be true. One or the other or both, okay? And so we can kind of build out logic that will help us answer some interesting questions. And we can even make more complicated statements. So let's say if I is greater than 5 and I is less than 10, or I is greater than 100. So if we use parentheses, we can actually guide the logic to make sure that each part is being evaluated how we want it to be evaluated. And then, of course, print this is true. And, of course, we can also nest our statements. We could say if I does not equal 7. We could nest this statement like this. So each level of indentation represents a layer of nesting. And so if I does not equal 7, print this is true. And you can see that it gets there as well. So this can be one of the most complex parts of programming, and that is figuring out the Boolean statement that gets you to the place you need to be to do your analysis. So for example, if you're writing a piece of code that counts words, you might want to check, have I seen this word before? And let's say you have a list in which you're storing the words that you've already seen. You can say, is this word in my list? If it's not, go ahead and add it to the list and then count it up. So there are lots of things that you'll be doing with these statements. And we're going to start combining them next time with loops. And these loops will allow us to execute the same code many, many times, so we don't need to rewrite it again and again. And we'll talk a little bit about writing our own functions, and then we're going to write some functions to count words in a document. Then we're going to talk about actually figuring out what a word is depending on the language we're using. We'll talk a little bit about lemmatization, and we're going to go from there. So we have about 12 minutes left, and yeah, it's 2:48. And so I am happy to stick around and chat and answer any questions. Otherwise, I hope everybody found this useful. As I said before, this stream will be up on my YouTube channel as soon as it ends. I think it takes maybe a few hours to process, and you can review it there. I'll put up the code on the GitHub repository, and we're gonna keep on trucking. Hopefully you enjoyed. So I guess that's that, and I'll be here tomorrow if folks continue to come back. So take care and enjoy your day, and I realize we're living through momentous times right now, and inauguration is tomorrow, but that'll be over before my stream starts. So I'm going to watch it. I hope everybody is as well. Anyway, I realize many of you may not be Americans, but I am, so I'll be watching the inauguration. But then I'll be here streaming once again. So, yeah, that's that. And come back tomorrow, please. Well, thank everybody for coming. I'm really glad people are actually tuning in, and my hope is people will also watch the recordings of this. I know that getting started in Python can be frustrating and confusing, but yeah, so the logic on line 81. Yeah, so here, essentially, the way this gets evaluated is first it checks, is I greater than 5? And is I less than 10? So this will be true as long as I equals 6, 7, 8, or 9, right? And so first it will evaluate this, and then it will check or I is greater than 100. So this statement here as a whole will be true if I is 6, 7, 8, or 9, or 101 and up. Okay? So as long as it's 101, so for example, if I change this to 101 and I run this again, you see it doesn't actually You see the second this is true, it doesn't execute because, let's see here. Oops, did I mess something up? I equals 101. This should, oh, right. This one did execute, this one didn't, right? Because in this particular case, let's just, here I'll go ahead and let's make these print different things. Print I does not fall in this range. And here I'll print I. And then here I'll add I here as well. Okay. So now we can see I does not fall in this range 101, and this is true. So basically, if I is 101, this whole thing is true. Or if I is 6, 7, or 8, this is true. But then on this next line, it checks, is it not 7? So if it is 7, then this doesn't end up executing. So if I change this to 7, then we can see that that second one doesn't execute. So hopefully that makes sense. And one other way that we could do this, we could actually print all of these individual statements out. So we could print I is greater than, I is greater than 5. Sorry for the suggestions there. So I is greater than 5. We could do I is less than 10. We can print this statement. We can print I is greater than 5 and I is less than 10. And we can print I is greater than 100. And then we can print the whole thing. And we can see how these different things get evaluated. So we can see it's true, 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 false, true. Hopefully that helps clear things out, clear things up a little bit. So yeah, I think we'll call that good, unless there are any last questions. The 5-second delay is a little disconcerting because it's not always immediately clear. Folks have things to say. All right, well, I think I'm going to call it good there, and I'll see everybody tomorrow. Take care, and always feel free to comment on the stream as well with additional questions.